Hello everybody. This is our presentation for Group 1 on Chapter 13. As you know, with any organization that develops software, there is an architecture that exists for that organization. We're going to go over the various problems that may arise with architectural we're going to go over problems that may come up with software architecture that's in place and ways that we can transition to a new architecture that would be better suited for the organization's needs. Some archetypes can cause issues. So LinkedIn, Google, eBay, Amazon, Etsy, these are all examples of companies that used an architecture that was causing problems for them who had to change their architecture. eBay, for example, used a technique called the Strangler application pattern. This phrase was coined by Martin, what's his name? Why do I not have this up? Okay. Fowler, that's it. Okay. eBay used a technique called the Strangler pattern. eBay used a technique called the Strangler application pattern instead of the rip and replace method that's often used. The Strangler application pattern was coined by Martin Fowler. He was actually observing as he was visiting Australia that there is a fig tree that would be engulfed by this vine. Vine would seed the fig tree and eventually it would grow downward until the root went into the soil, and then over the years it would grow into a beautiful shape, but meanwhile it would strangle the tree and kill it. So the strangling pattern, application pattern, was coined by Martin Fowler, and we'll talk about that a little bit later. Tightly coupled architectures are usually volatile and have a high risk of failing when code is committed to the trunk. A lot of times people will make even small changes, and because it's so tightly coupled and everything is so dependent on exactly how that is created or how that is used, a lot of time and resources, well, a lot of times it'll require a lot of resources to fix what is broken. And this also results in less frequent deployments. So steps have to be taken to reverse the downward spiral caused by a tightly coupled architecture. So when we work in an architecture that doesn't work, or if we have to change, or whatever the cause may be, architecture that enables productivity is, it just depends on your situation. So for example, with the Google Cloud Data Store, they're actually known for having the largest, where is it? Where did I note that? Google. Well-defined interfaces, okay. Okay, so Google and Amazon are both service-oriented architectures. With the Google Cloud Data Store, I don't think I wrote any of this down. Let me find it in the book. Google Cloud Data Store. With the Google Cloud Data Store, hold on. Okay, the Google Cloud Data Store is one of the largest NoSQL services in the world. You can see by these layers, it is created by layers, and this is a good example of a decoupled architecture. You can see that there's a cloud data store, there's a megastore, a big table, a Colossus, and a cluster management infrastructure. So You can see that this type of architecture has served Google extremely well for a service like Gmail. There's 5 or 6 other layers or services underneath it.
Okay, so it's going to be my job to tell you a little bit about our monolithic versus microservices and just some of the pros and cons with the microservices specifically. Some of the pros is that each unit is simple, it's an independent scaling and performance, it has independent testing and deployment, and it can be optimally tuned for performance, such as in caching and replication. Some of the cons, though, is that it takes many cooperating units, many small repos, and requires a more sophisticated tooling and dependency management. It also can cause much or a lot of network latencies. Next, we're going to talk about the evolutionary architecture and specifically the evolutionary architecture at Amazon. Now, it started with Obidos, which is a monolithic application running on a web server. After some time, Obidos got too complicated to promote a software environment that would allow things to be done that would like to be done. They decided that moving to a service-oriented architecture would allow them to build software components rapidly and independently. And they learned several lessons in this transition to their new architecture. The first one is that strict service orientation is an excellent technique to achieve isolation. The next lesson they learned is that you can avoid evolving your clients by prohibiting direct database access when performing scaling and reliability improvements to your service state. And the third is they learned that switching to a service orientation enables teams to quickly innovate with a strong customer focus. They went from approximately 15,000 deployments per day in 2011 to 136,000 deployments per day by 2015.
My name is Jeremiah Price, and I'll be talking to you about the Strangler application pattern. The term came from Martin Fowler when he observed vines slowly strangling existing trees that they grew on over time. It refers to the act of slowly developing a new architecture while using the old one and eventually choking out the old architecture. This is done when businesses are needing something new, something more efficient, more effective, but their old system is already utilized 100%. Well, they start taking away chunks of it slowly over time until eventually they have the old system gone and a brand new system. And this is called the Strangler application. Old calls are called to the old architecture from the new one using an API to the old one. Then no changes are made to the old implementation behind the API while this is taking place. We need to avoid the new application to get too tightly coupled into the other services by creating new versions of the API and migrate teams to new services instead of modifying the old ones. The legacy application will shrink in functionality as functionality is continually decoupled and new API versions are developed. This has been seen with Blackboard back in 2011. Starting out, it was a small application that used legacy J2EE codebase that went back to 1997, a very old code language. In 2010, the code was more complex and more error-prone when building and integrating and even testing. The company fell behind and started seeing its growth decline. The number of comments decreased in 2010 dramatically due to difficulty to work with the code. The code became outdated and their architecture started to fall apart. Because Blackboard learned to use the monolithic architect type, they didn't have any room for growth. There was no scaling in their architecture type. So they used the Strangler pattern to redesign the code architecture. They decoupled various modules for people to work in independent blocks. They took blocks of their original code and started developing teams for those blocks that eventually took over the old architecture, allowing them to produce more lines of code. Any mistakes were small local failures instead of major catastrophes that impacted the global system, which is a big downfall of monolithic architecture types. Now, in conclusion, Architecture is one of the top predictors of the productivity of those who work in it and of how changes can be quickly and safely made. It's important to be able to safely migrate from one architecture to another because as the organization grows, the type of needed architecture will evolve. There are examples of architecture migrations that we can look at when we need to change architecture. Google, Amazon, Blackboard are great examples of companies that have taken a complicated and twisted architecture to something more simple and more effective. Especially with Google using microservices to build their code rather than having everyone work on the same problem. And Blackboard is another great example of taking an old architecture, eventually killing it and strangling it with a new type of system that is way more effective. We can see here the DevOps model is very clear when it talks about having small teams or pizza cutter teams and implementing an effective way of communicating and keeping code and everything simple. And Sean Taub, this is for you, bud. The boy with the biggest dreams, man. Go get him, Tiger.